Good morning, dear students. So now last class ಅಲ್ಲಿ nuclei topic ಗೆ ಸಂಬಂಧಪಟ್ಟಾಗೆ radioactivity. What is meant by radioactivity and what are the properties of alpha rays, beta rays and also gamma rays. So ಅದರ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ತಾ ಹೋಗಿದ್ದೆ. So ನಾವು ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾ ಹೋಗೋಣ. That is chapter 13 nuclei. So in that we will see the law of radioactivity or the radioactive decay law. Law of radioactivity or decay law. So what is the statement of this law? What is the statement of the radioactive decay law? So it states that the rate of disintegration of the radioactive sample is directly proportional to the number of atoms present at that instant of time. See, this law states that the rate of disintegration of radioactive sample is directly proportional to the number of atoms present at that instant of time. That is the statement of the radioactive decay law. See, it states that the rate of disintegration of the radioactive sample is directly proportional to the number of atoms present at that instant of time. So, ಒಂದು radioactive sample ನಲ್ಲಿರುವಂತಹ number of atoms. So, the disintegration depends upon the number of atoms present in the radioactive sample. Or number of atoms ಮೇಲೆ depend ಆಗಿದೆ. So, that is given dN by dt. Here the line represents the radioactive sample. dN by dt means the rate of disintegration of the radioactive sample. The rate of disintegration of the radioactive sample is directly proportional to the number of atoms. N be the number of atoms. That is dN by dt directly proportional to N. To remove the proportionality, we put the constant. That is dN by dt is equal to minus lambda into N, where lambda is the decay constant. Lambda represents decay constant. And the negative sign. Here the negative sign represents the number of atoms in a radioactive sample is decreases as the time goes on. Time ಜಾಸ್ತಿ ಆದಾಗೆಲ್ಲ ಏನಾಗ್ತದೆ, number of atoms decrease ಆಗ್ತದೆ. So the negative sign represents the number of atoms will decreases as the time increases. So time ಜಾಸ್ತಿ ಆದಾಗೆಲ್ಲ ಏನಾಗ್ತದೆ, number of atoms decrease ಆಗ್ತದೆ. Lambda represents the decay constant. N with the number of atoms in a radioactive sample. So this is the law of radioactivity or decay law. So next we will see the expression for the number of atoms present in a radioactive sample at any time t. ಸೊ ಒಂದು ರೇಡಿಯೋ ಆಕ್ಟಿವ್ ಸ್ಯಾಂಪಲ್ ಅಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಆಟಮ್ಸ್ ಇದೆ. ಸೊ ಆ ನಂಬರ್ ಆಫ್ ಆಟಮ್ಸ್ ಗೆ ನಾವು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಕಂಡುಹಿಡಿಯಬೇಕು. ಸಿ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ number of atoms present in a radioactive sample at any time or so ಇದನ್ನ ಇನ್ನೊಂದು ರೀತಿ ಕೇಳಿದ್ರೆ prove that n is equal to n naught e to the power of minus lambda t. So equation prove ಮಾಡಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಅಥವಾ there are the expression for the number of atoms present in a radioactive sample at any time t. ಯಾವುದೇ ಟೈಮ್ ಅಲ್ಲಿ ಒಂದು ರೇಡಿಯೋ ಆಕ್ಟಿವ್ ಸ್ಯಾಂಪಲ್ ಅಲ್ಲಿ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಆಟಮ್ಸ್ ಇದೆ ಅದಕ್ಕೆ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಡಿರೈವ್ ಮಾಡಿ ಅಂತ ಹೇಳಿದಾನೆ. or derive n is equal to n naught e to the power of minus lambda t. Prove that ಅಂತ ಹೇಳ್ತಾರೆ. So now let's see. Let n is equal to n naught e to the power of minus lambda t. So ಈ ಕ್ವೆಶ್ಚನ್ ಪ್ರೂವ್ ಮಾಡಿ ಅಂತ ಹೇಳಿ. Now see, let us consider n naught be the number of atoms at the time t is equal to 0 second. That is at the time t naught. At the time t naught second. Let n naught be the number of atoms at the time t naught second. Then n be the number of atoms. N be the number of atoms at the time t second. So initial ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ number of atoms n naught ಇರುತ್ತೆ. But at the time t second ಆದ್ಮೇಲೆ n be the number of atoms. Then dn be the number of atoms disintegrate. Then be the number of atoms disintegrates at the time in the short interval of time dt. N naught be the number of atoms at the initial time t naught, and n be the number of atoms at the time t second. Then dn be the number of atoms after disintegrates at a time small interval of time dt. So now we know that according to the decay law, according to the radioactive decay law, dn by dt is directly proportional to n. The rate of disintegration of the radioactive sample is directly proportional to the number of atoms. So to remove the proportionality, we put the constant lambda dt is equal to minus lambda n, where lambda is the decay constant. So now the equation of the small arrangement ಮಾಡ್ಕೊಡ್ತೀನಿ. See, dn divided by n ಇದನ್ನ ಈ ಕಡೆ ತಗೊಳ್ತೀನಿ, dt ನ ಈ ಕಡೆ ತಗೊಳ್ತೀನಿ, minus lambda into dt. So this is equation 1. Now integrate equation 1 on both sides. Equation 1 ಅನ್ನು ಏನು ಮಾಡ್ತೀನಿ, integrate ಮಾಡ್ತೀನಿ. That is integration dn by n is equal to integration minus lambda into dt. So ನಾನು ಇಲ್ಲಿ arrangement ಮಾಡ್ಕೊಳ್ತೀನಿ. See, 1 by n into dn, integration of 1 by n into dn is equal to minus lambda is constant. ಸೊ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರೋದು ಏನು ಮಾಡ್ತೀನಿ, ಇಂಟಿಗ್ರೇಷನ್ ಹೊರಗಡೆ ತಗೊಳ್ತೀನಿ, ಮೈನಸ್ ಲ್ಯಾಂಬ್ಡಾ ಇಂಟಿಗ್ರೇಷನ್ 1 ಇಂಟು dt. ಸೊ ನಮಗೆ ಜನರಲ್ ಫಾರ್ಮುಲಾ ಗೊತ್ತು. ಸೊ ಏನಪ್ಪ, 1 by x into dx. The integration of 1 by x into dx is log base ex. It's an integration formula. So ಇಲ್ಲಿ 1 by n into dn ಅದೇ ಫಾರ್ಮುಲಾ ನಾನು ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದಾಗ log base e n ಅಂತ ಬರೆಯಬಹುದು. log base e n. This is equal to minus lambda into 1 into dt, constant term integration ಮಾಡಿದ್ರೆ t plus c, where c is the integration constant. C is the integration constant. C is the integration constant. So then log base e n is equal to minus lambda t plus c. In order to evaluate the integration constant of c, so now integration constant na ಕಂಡುಹಿಡಿಯಬೇಕಾದ್ರೆ put the initial conditions. What are the initial conditions? N is equal to n naught, t is equal to t naught, that is 0 second. T is equal to 0. Initial conditions na substitute. What are the initial conditions? N is equal to n naught, t is equal to 0 second. So equation 2 ನಲ್ಲಿ initial condition substitute ಮಾಡಿ. So initial condition substitute ಮಾಡಿದಾಗ log base e n, log base e n naught is equal to minus lambda t ಅಂದ್ರೆ 0 plus c. So lambda into 0 is 0 and here c value is c is equal to log base e n naught. So ಈ ಇಂಟಿಗ್ರೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನು ಈಕ್ವೇಷನ್ 2 ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ಸೊ ಈಕ್ವೇಷನ್ 2 ಏನಿದೆ, log base e n is equal to lambda t plus c ಅಂದ್ರೆ log base e n naught, log base e n naught. So substitute. So log base e n naught n is equal to minus lambda t plus log base e n. So log ಇರೋದನ್ನ ನಾನು ಏನು ಮಾಡ್ತೀನಿ, 1 ಕಡೆ ತಗೊಳ್ತೀನಿ. ಸೊ ಇದನ್ನ ಲೆಫ್ಟ್ ಸೈಡ್ ತಗೊಳ್ತೀನಿ, log base e n. ಇದನ್ನ ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ minus log base e n naught is equal to ಏನಾಗುತ್ತೆ, minus lambda t, minus lambda. So according to the properties of logarithm, so logarithm properties ಪ್ರಕಾರ ಇದನ್ನ log base e n divided by n naught ಅಂತ ಬರೀ, n divided by n naught, log base e n divided by n. So by the properties of the logarithm, it is equal to minus lambda t, minus lambda. So in base e n divided by n. So exponential of log base e to the power of minus lambda t. Now n ಅನ್ನು ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡ್ತೀನಿ, n is equal to n naught e to the power of minus lambda. Equation 12. The expression for the number of atoms present in a radioactive sample, that is n is equal to n naught e to the power of minus lambda t. Therefore, the number of atoms in a radioactive sample is decreases exponentially as the time increases. So time just exponentially decrease after the number of atoms. So this is the expression for the number of atoms in a radioactive sample at any time t. N is equal to n naught e to the power of minus lambda t. See decay constant lambda or radioactive constant. Decay constant or radioactive constant. So now what is meant by the decay constant or the radioactive constant? Here see, the decay constant is the reciprocal of the time during which the number of atoms is decreases 1 by E times the initial value of the atoms. So decay constant here is the reciprocal of the time. So our time, the number of atoms, a radioactive sample allironತಹ number of atoms, so 1 by E times ಅಷ್ಟು decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Initial value ಗಿಂತ 1 by E times decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So that is called a decay constant. The decay constant is the reciprocal of the time during which the number of atoms in a radioactive sample decreases 1 by E times the initial value. So we know that N is equal to N naught e to the power of minus lambda t. So this is from the radioactive decay law. N is equal to N naught e to the power of minus lambda t. So decay constant is the reciprocal of time. Lambda is equal to 1 by t. So 1 by t now substitute ಮಾಡಿದ್ರೆ equation ಅಲ್ಲಿ N is equal to N naught e to the power of minus lambda ಅಂದ್ರೆ 1 by t into substitute t get cancelled. Hold it up. N is equal to N naught e to the power of minus 1. So e to the power of minus 1. ನಾನು denominator ತಗೊಂಡ್ರೆ plus 1. Therefore N is equal to N naught e to the 1 by e. That means N is equal to 1 by e into N. So the value of E is 2.178. So ಈ ವ್ಯಾಲ್ಯೂ ನಾನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ N is equal to 1 divided by ಈ ಜಾಗದಲ್ಲಿ 2. So sorry, it is 718 into N. So 1 divided by 2.718 is equal to 0.37 times of N. That means N is equal to 37% of N naught. So this is about the decay constant or the radioactive constant. It is the reciprocal of the time during which the number of atoms in a radioactive sample is decreases 1 by E times the initial value. So initial atoms ಗಿಂತ 1 by E times ಅಷ್ಟು ಏನಾಗುತ್ತೆ number of atoms decrease ಆಗುತ್ತೆ. So that is about 37% decrease ಆಗುತ್ತೆ. ಯಾವುದು initial number of atoms ಗಿಂತ 37% decrease ಆಗುತ್ತೆ. So this is about the decay constant or the radioactive constant. So next see activity of a radioactive sample. Activity of a radioactive sample. So what is meant by the activity of a radioactive sample? The rate of disintegration of the radioactive sample at that instant is called the activity of the radioactive sample. That is the rate of disintegration. The rate of disintegration of radioactive sample. The rate of disintegration of the radioactive sample at that instant. At that instant is called activity of that radioactive sample. So now the activity, the rate of disintegration of the radioactive sample at that instant allow disintegration, a radioactive sample in disintegration, and now activity of the radioactive sample at the activity of the radioactive sample, that is A. A is the activity equal to the rate of disintegration of the radioactive sample, that is dN by dt. According to the radioactive decay law, we go to dN by dt is equal to minus lambda into n, minus lambda into n, according to the decay law. So here the activity means the rate of disintegration of the radioactive sample at that instant is called the activity. Then activity is represented by A, that is equal to dN by dt. Then dN by dt is equal to lambda. Then A is equal to lambda. A is equal to lambda n. That means A is directly proportional to n. A is directly proportional to n. That means activity is directly proportional to the number of atoms present in a radioactive sample. So we know that the number of atoms in a radioactive sample is n is equal to n naught e to the power of minus lambda t. Here A is directly proportional to n, then AD is equal to a naught e to the power of minus lambda t. Activity by why? Because A is directly proportional to n. We know that n is equal to n naught e to the power of minus lambda t. Then AD is equal to a naught e to the power of minus lambda t, where a naught is the activity. A naught is the activity at the time t second. So A naught be the before the activity, that means before the disintegration. This is after the disintegration. AD represents after disintegration, and what is the before disintegration. A represents activity, and the unit for activity, we have three different units in order to express the activity. Now let's see one by one. So this is the activity of the radioactive sample, that is the rate of disintegration of a radioactive sample at that instant, that is given by AT is equal to A naught e to the power of minus lambda t. So we have to express the activity in three different units. Now let us see what are the different units of the activity. So the first one is Curie. Curie is the unit, one unit of the activity. 1 Curie is equal to 3.6 into 10 to the power of 10 disintegration per second. Disintegration per second. That is the one of the unit of the activity. So first one unit has 1 Curie. That value in terms of disintegration per second is 3.6 into 10 to the power of 10 disintegration per second. And the second unit, that is 1 Rutherford. 1 Rutherford. That 1 Rutherford is also unit of the radioactivity. Activity of the radioactive sample. And 1 Rutherford is equal to 10 to the power of 6 disintegration per second. Disintegration per second. Then we have the another unit, that is 1 becquerel. That is equal to 1 disintegration per second. 1 disintegration per second. Therefore, the unit of activity is Becker. So now ಏನು ಮಾಡ್ತೀವಿ Becker ಅಲ್ಲೇ express ಮಾಡಿ. So the activity of the radioactive sample has the three different units. One is Curie. The value of 1 Curie is 3.6 into 10 to the power of 10 disintegration per second. And another unit is 1 to the 4. And it has the value 10 to the power of 6 disintegration per second. And the third unit is the 1 Becquerel, that is equal to 1 disintegration per second. Hence, we can express the activity in Becquerel. The SI unit of the activity is Becquerel. So now unit of activity anta kelidaga Becquerel anta barutte. So this is about the activity of the radioactive sample. So next see off life period. Off life period. So now what is meant by off life period? See, the time taken by the radioactive sample to disintegrate 50% of the sample is called the off life period. So ಒಂದು radioactive sample ಅರ್ಧದಷ್ಟು ಡಿಸಿಂಟಿಗ್ರೇಟ್ ಆಗೋದಕ್ಕೆ ತಗೊಳ್ಳೋಂಥ ಟೈಮ್ ನಾವು ಆಫ್ ಲೈಫ್ ಪೀರಿಯಡ್ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಈಸ್ ದ ಟೈಮ್ ಟೇಕನ್ ಬೈ ದ radioactive sample, the time taken by the radioactive sample to disintegrate 50% of the sample. 50% of the sample is called off life period. So off life period. So ಒಂದು radioactive sample ಅಲ್ಲಿ ಅರ್ಧದಷ್ಟು ಡಿಸಿಂಟಿಗ್ರೇಟ್ ಆಗೋದಕ್ಕೆ ತಗೊಳ್ಳೋಂಥ ಟೈಮ್ನ ನಾವು ಆಫ್ ಲೈಫ್ ಪೀರಿಯಡ್ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಈಸ್ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಬೈ ಟಿ ಆಫ್. ಸೊ ಇಲ್ಲೊಂದು ಕ್ವಶನ್ ಅರೈಸ್. ಸೊ ಡಿರೈವ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ಆಫ್ ಲೈಫ್ ಪೀರಿಯಡ್ ಆಫ್ ಎ ರೇಡಿಯೋ ಆಕ್ಟಿವ್ ಎಲಿಮೆಂಟ್ ಅಂತ ಹೇಳ್ತಾರೆ. ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ದ ಆಫ್ ಲೈಫ್ ಪೀರಿಯಡ್ ಆಫ್ ದ ರೇಡಿಯೋ ಆಕ್ಟಿವ್ ಎಲಿಮೆಂಟ್. ನೌ ಸಿ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ದ off life period of the radioactive element. Expression for expression for off life period of a radioactive sample or radioactive element. So expression derive ಮಾಡಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಅಥವಾ for or derive T of is equal to 0.693 divided by lambda. So equation derive ಮಾಡಿ ಅಂತ ಹೇಳ್ತಾರೆ. That is the equation for the off life period of a radioactive element. So now derive. So let us consider N0 be the number of atoms. N0 be the number of atoms present in a radioactive sample at the time t is equal to 0 second. So 0 second time alli n0 number of atoms irtavadalli in a radioactive sample. N0 be the number of atoms present in a radioactive sample at a time t is equal to 0 second. Then n be the number of atoms. N be the number of atoms present in a radioactive sample at time t second. So generally we can say that it is t second. N naught be the number of atoms. So time 0 iddaga N naught number of atoms radioactive sample alli irtade. Then time t second alli N be the number of atoms in a radioactive sample. So we know that the radioactive decay is given by N is equal to N naught e to the power of minus lambda t. That is equation. This is the radioactive decay law. The number of atoms in a radioactive sample. So now what it is expression for the half-life period of a radioactive sample. So put N is equal to N divided by 2 and T is equal to T of in the above equation. So half-life period. So 50% of the sample disintegrate ಆಗೋದಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಅದನ್ನ ನಾವು ಹಾಫ್ ಲೈಫ್ ಪೀರಿಯಡ್ ಅಂತ ಕರೀತೀವಿ. ಸೊ ಅದಕ್ಕೆ n divided by 2 n is equal to n divided by 2 t is equal to t of that. Equation 1 ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ so this is n naught divided by 2 n naught divided by 2 n ಜಾಗದಲ್ಲಿ n naught divided by 2 is equal to n naught e to the power of minus lambda. T ಜಾಗದಲ್ಲಿ t1 by 2 ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ t1 by 2. So n naught cancel ಆಗುತ್ತೆ. ರಿಮೈನಿಂಗ್ ಉಳಿದಿದ್ದು 1 by 2 is equal to e to the power of minus lambda t of. So now this is equation 2. See 1 by 2 is equal to e to the power of minus lambda t1 by 2. So now reciprocal and the denominator toward positive. 1 by 2 is equal to 1 divided by e to the power of lambda t1 by 2. So that is minus ididu kelagade bandre enagutte plus adu. Nanu idನ್ನ reciprocal ತಗೊಂಡ್ರೆ 2 is equal to e to the power of lambda t of. So ಈ equation ಗೆ ನಾನು taking out log on both sides. That is log base e 2 is equal to log base e to the power of lambda t by 2. So we know that the formula. Therefore log base e to the power of x is equal to x. So logarithm formula log base e to the power of x is equal to x. Log base e to the power of x anta ide. So now e to the power of x is equal to x anta bರುತ್ತೆ. That is so log base e 2 is equal to log base e to the power of x. That is x form ಬರ್ತದೆ lambda into t to the of t 1 by 2. So now log base e to log 2 value ಕೊಡಬೇಕಾದ್ರೆ 2.303 into log base 10 into 2. So log base e na log base 10 ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ 2.303 is equal to lambda t1 by 2. So now log base 10 ಅಂದ್ರೆ log 2 value ಬರುತ್ತೆ 2.303 into 0.3010. That is the value of log 2 base 10. That is equal to lambda t by 2. So ಇದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಮಗೆ 0.693 is equal to lambda into 1 by 2. So ನಮಗೆ ಬೇಕಾಗಿರೋದು ಆಫ್ ಲೈಫ್ ಪೀರಿಯಡ್. ದಟ್ ಈಸ್ t of period is equal to 0.693. ಇದರ ಡಿನೋಮಿನೇಟರ್ ಬರುತ್ತೆ that is lambda. So this is the expression for the half life period. From the expression you can say that the half life period of a radioactive sample is inversely proportional to the decay constant. So it is inversely proportional to the decay constant. That is T of is equal to 0.693 divided by lambda. So this is the expression for the half-life period of a radioactive sample, that is given by T of is equal to 0.613 divided by lambda. ಸೊ ಇವತ್ತಿನ ಕ್ಲಾಸು ನಿಮಗೆ ಅರ್ಥ ಆಗಿದೆ ಅಂದ್ಕೊಳ್ತಿದ್ದೀನಿ. ಸೊ ಇಲ್ಲಿ ಅಸೈನ್ಮೆಂಟ್ ಕ್ವಶನ್ಸ್ ಇದೆ, ಆ ಕ್ವಶನ್ಸ್ಗೆ ಬರೆದ್ಬಿಟ್ಟು ಆನ್ಸರ್ ಮಾಡಿ ಗ್ರೂಪಿಗೆ ಸೆಂಡ್ ಮಾಡಿ. ಸೊ ಥ್ಯಾಂಕ್ ಯು.